Hello everybody, welcome to today's tutorial. In this video we are going to be looking at how to rationalize the denominator of a solved expression. And we're going to look at two questions. We're going to solve two questions to lay the precedence for today's class. Now, the first thing you need to know is that these expressions are what we call binomial solved because they have two expressions. I guess now. So we call this expression binomial. Bi means two. I guess now. So root 3 minus 1 is a binomial sort. Now, the concept of rationalization is on the basis that now we are rationalizing the denominator now. So we know that the denominator is the value that is in the lower side of that's in the lower side of a fraction. I get me now. So the upper value is your numerator, the lower value is your denominator. So what we want to do is to rationalize the denominator. And the concept of rationalizing is that we take the conjugate of the denominator. What do I mean? Now, the expression of the conjugate in the first example is root 3 plus 1. The conjugate of this expression is the same expression but with a change of sign. So what you are doing when you are rationalizing the denominator is that you are going to be changing the sign of whatever values in your denominator to the opposite sign. I get me now. So if you have the addition, it becomes subtraction. If that you have a subtraction, it becomes what? Addition. Now, for us to be able to solve this question now, what we simply need to do is that we are now going to say root 3 minus 1 over root 3 plus 1 multiplied by the value of our conjugates. Now that's root 3 minus 1 over root 3 minus 1. So it means that we are going to multiply both the numerator and the denominator by the conjugate of what? Of the denominator. So it is on this basis that we are going to proceed with further calculations of this question. So remember that when you are performing rationalization of the denominator, you multiply both the numerator and the denominator by the conjugate of what? The value of your numerator. I get me now. Please remember how we performed addition and subtraction and multiplication of solid in previous videos. I'm going to apply that knowledge in this particular question. So let's move on. Let's solve. So we have root 3 multiplied by root 3, that will give us root 9. Root 3 multiplied by minus 1, that's minus root 3. Minus 1 multiplied by root 3 is minus root 3 again. And minus 1 times minus 1 will give us plus 1. Then here we have root 3 multiplied by root 3, that's root 9. Root 3 multiplied by 1, that's minus root 3. Plus 1 multiplied by root 3, that's plus root 3. Then 1 plus 1 multiplied by minus 1, that's going to give us a negative 1. I get it now. So obviously some of our expressions are perfect squares. I have a perfect square root. So for 9 now we have, this is going to become 3. So this is minus 3 root 3 minus root 3. And you know that we said that when we are performing addition and subtraction of such, the values in the sort must be the same. I get it now. So in this case, since it's root 3, we can perform the subtraction. So when we do minus 3 minus 3, this will give us minus 2 root 3. Because this is basically like saying minus 1. So like we have a 1 value on the outside. So when you add the 1 together, you have a 2. Then you have plus 1. In the case of the denominator, root 9 will also give us 3. But minus 3 plus 3 plus root 3 minus root 3 plus root 3 will cancel out. Because the minus and the plus will negate themselves. I get it now. So be left with minus 3 minus 1. So in this case, we are going to be left with. So we collect the like terms in this expression. So we have 3 plus 1, which will give us 4, minus 2 root 3 over 3 minus 1 will give us 2. Yes, so we have arrived at our answer, but we need to simplify this further. I get me now. Since this is a fraction, this also simply means that this also can be written as an expression of, say, 4 over 2 minus 2 root 3 over 2. So we know 2 can divide 4 to give us 2, and this 2 can divide this 2 to give us 1. So this expression will now become 2 minus root 3. So this is the simplified form of this particular answer. So this is the answer to this particular expression, rationalizing the denominator. So for the first example, this is our solution to it. Now let's attempt the second one. So we have 5 root 3. So we're going to follow the same principle of what we have done here. So let's multiply this. Like I said, the conjugate of the denominator. So that will be 7 minus 4 root 3 over 7 minus 4 root 3. Yes, so let's multiply 5 times 7. That's going to give us 35. 5 times 4 root 3. 5 times 4 is 20. So that will be minus 20 root 3. 2 root 3 multiplied by 7. That is plus 14 root 3. Then plus 2 root 3 multiplied by 4 root 3. That will give us 2 times 4 is 8. So that's minus 8. And root 3 times root 3. That's going to give us root 9. I told you that when we are performing multiplication of sub expressions, you have to multiply the values inside the square roots. I get it now. You have to multiply the square root values together. So it's not like the addition where we retain the same figure. So let's multiply. So 7 times 7 here is 49. 7 times minus 4 root 3 is minus 28 root 3. Plus 7 times 4 is plus 28 root 3. And that's going to be 16. So that's going to be minus 4 times 4 is 16. Root 3 times 3, that's root 9. So let's break down all of these expressions and collect. Let's first break it down. Let's take the values of the perfect square roots that we have here first. They are going to arrange them in like terms. So we are going to have 35 minus. So let's first take the value of the perfect square root. So 14 root 3 minus 8. So perfect square root of 9 is 3. So 8 times 3 will give us 24. All over 49 here minus 28 root 3 plus 28 root 3 minus 16. 16, the perfect square root here is 3. So 16 times 3 will give us 48. Let's make this 48. 16 times 3, that's the square root of 9 will give us 3. So 16 times 3 will give us 48. Now, so let's collect our like terms and remove every other expression that needs to be removed. So 35 and 24. So 35 minus 24, right? The minus 20 plus 14 give us minus 6 root 3. Because minus 20 and plus 14. So minus 20 is greater than plus, so you are going to have a negative 6 root 3 over. Definitely these two expressions will cancel out themselves. So you are going to be left with 49 minus 48. So if we take the subtraction of this value, 35 minus 24, we are going to be left with 11 minus 6 root 3. And if you take the subtraction of 49 from 48, you are going to have a value of 1. So invariably, I can leave my answer as 11 minus 6 root 3. One thing that I want you to note is that when we are multiplying the value of the denominator, you find out that the two middle values will always cancel out. You can see here and in this case. So what you can simply do if you are in a time, you find yourself time constrained, is just to multiply this by this and this by this to get the values of what will be left. I get it now. So you don't really need to, except you are solving a question where you're expected to expatiate on show the steps of your workings. I get it now. So you just simply do this multiplied by this will give you root 9, and 1 multiplied by 1 will give you this minus 1. I get it now. So when you take the root 9, you have 3 and the minus 1 here. The same thing also applies here. 7 times 7, 49. If you do 4, if you multiply this together now, this will give you this value. So you may not necessarily have to generate some new values since they will cancel out themselves. I want you to follow the steps of how I solve these two questions, apply them in a particular question that you have. I want you to perfect your knowledge of rationalizing the denominator of a binomial sort or any kind of sort. So I look forward to seeing you in the next video. And next video I'm going to do with something else. I want you to like, subscribe, share this video with your friends. It's very important. Help us grow together. And I'll see you in the next video. Thank you.